So I am Ferreol Soulez. I am astronomer in Lyon, France. So I will present you OImaging on the behalf of the whole GMC MFIR team. So MFIR is a model fitting and image reconstruction group. So I am in remote, but Laurent Bourgès and Guillaume Mella are in Exeter. So they will be able to answer some of your questions in place. Okay, so OImaging is not image reconstruction software, but it's just a graphical user interface for image reconstruction software. Okay, so in a nutshell, as everyone probably knows, so we observe some object like this star, and with our instrument, interferometric instrument, but we get only closure phase or visibility data, and from this visibility data, we want to recover an image of the object, and that is the goal of image reconstruction. So over the last decades, so few decades, there was a bunch of image reconstruction software that have been proposed. So I list some of them here. So the most famous one, but if you want to try this software, then you have to install it, and many of them are in different language. So for many C or Yorick or Python. So and every time you want to try a new software, you have to install all the library, and it can be a bit cumbersome depending on the software. So the idea of OImaging is to provide a single interface for all of this software, and to allow a user to compare software, because as usually what people are usually doing when they reconstruct some images, they use several reconstruction software to see if it's if the image is more or less the same in all this software, to have more confidence in the reconstruction. So here is, for example, the PGRU data from Claudia Palladini, who try Squeeze and Myra, the Betelgeuse by Xavier Bois, who try BSMM and Myra, and AirSculpt by Witowski, who try IRBIS, Myra, and BSMM. So if you want to publish that kind of paper, you have to install several software and try to understand how it works. And so the idea behind OImaging is to make the user life simpler by providing a single interface with more or less the same parameters for all softwares. Okay, and another things you want to compare when you are doing image reconstructions, even with a single software, you want to compare some different priors to change some parameters, and to compare the result of the regression depending on the initialization image. So as was done by Jacques Lusca here in this paper. So I don't have enough time to make you a demo, but I have done a demo on YouTube. You can look at it on the GMC web page, but I can at least show you some image. So I will. So the typical workflow would be to read the OIFITS file with OIFITS Explorer, and then filter it and send it to OImaging. That is the interface of OImaging. And here you can, on this panel, you can select the algorithm you want to use. So there is only up to now only 4 BSMEM, Myra, Sparko, and Wizard algorithm, but we hope that it will be possible to add more. And so you have some short documentation about the parameter of each software. You can change a parameter here, and then when you run it, you have a result panel here, and in this result panel you can record all the reconstruction you have. So here with a air car image from the beauty contest of 2014. So you can reconstruct quickly with several algorithm air car, and you can have all these results in this table and look at the image. So for example, comparing different parameters and different initial image, and you can also compare by this kind of by comparing like this, comparing two images. You can add some ratings, look at the chi-square, look at every parameter that are stored in this table. So and select the ones that you like. You have also other tools, like for example, on this reconstruction of delta score, it's a binary, so you can use image reconstruction just to have a glimpse of where are the two objects, and we are able to reconstruct here the two objects, and there is a small ruler that you can use to measure the distance between the object and the PA. You can also measure the width of the star and so on. And so that's more or less the demonstration. So you can also find a video about the workflow of with GMC tools on the GMC webpage. Okay, and all of this was possible because we with image reconstruction people, we define some interface, so just a standard to put everything in OIFITS file to run software, and every software should be able to read the parameter in the OIFITS file and write the output in another OIFITS file. And it's very simple to make communication between softwares. Okay, so we make a new release of OImaging this week, so you can check out. We make a lot of work thanks to CNRS fundings to improve OImaging, and do not hesitate to ask some feature and report bugs. And if you need help, do not forget that you can use VLTI Expert Center to help you to recover some images. And as a conclusion, I just want to thank everyone in GMC and all the people involved in the development of OImaging. Thank you very much.
Thank you, Ferreol. Any questions for Ferreol? Okay. Do you have any questions?
So far.
Mm-hmm.
Not online.
Not online. Okay. Yeah. Ferreol, just a question. So you mentioned that basically you can unify all the image reconstruction software, so you can use everything using this interface. I was just wondering. So basically, how easy is it to use the interface? Like, does it only because doing the image reconstruction process is quite complicated, but would we also be more efficient to do it by just using the image reconstruction software, or is just a tool to help us go from one software to the other and just compare between the two.
Yeah, exactly. It's just to help the user both to use the software, because some of the software are quite cumbersome to install on macOS, for example, and also to compare a software with another, compare results, and have like a common interface to be able to benchmark each software.
Okay, that's perfect. Thank you. Any more questions? If not, we can thank Ferreol again.
Thank you.